Hello everyone. In this video we are going to see how we can use Excel and some of these tools that we have in Excel in order to help us with a normal distribution problem. Okay, so let's look at our scenario. So it says that Harry has been studying the athletic performance of top XFit athletes. He knows that the winners of the XFit games can clean is normally distributed with 224 pounds as the mean and 441 pounds as the variance. Note that cleans are lift. Harry has been following a particular promising athlete, Jack, who can clean 255 pounds. Okay, so over here we're going to write out a little bit of information, and we can also put in some of our inputs. So for the mean, we know that the true mean here is 224. It was given to us in our poundage right here. So we can hit enter. Our standard deviation is just going to be equal to the square root of the variance which we were given. So we can just type in square root of 441. Is that what it gave us over here for our variance? Remember, this is mean and variance when it gives us in this shorthand notation. The other way that you know it's variance is because the original mean is in pounds and variance is in pounds squared. Okay, so we can hit enter. And we need to type about, okay, how many people are we talking about? And right now we're just talking about a single person, this guy named Jack. All right, so we've got one. And then over here, we're just going to put like a X underscore crit for like our critical point that we're interested in. And Jack, he particularly can do 255 pounds. And I'm just going to put pounds over here just so we've got some units on it as well. Okay, so now we have what percent of XFit competitors can clean more than Jack? Okay, so there's a couple ways that we can do this. So essentially, let's just take a look at our distribution. And we are seeing that, hey, Jack is right up about here at about 250. And so if we were to just to shade this in from 255 and above, what percent do we think can do more than Jack? So just from guessing, I'm going to guess that it's about 12%. And about 12% of people can clean more than Jack. Let's go ahead and use our tools up here. So we're going to go ahead and click on our values button. And our left value here is going to be equal to this critical point, this 225. And then the right position, we're going to make it really, really big. So I'm just going to type out like 500. Hit enter, and it says, oh, 12% was a little high. It is closer to like 7%, 0.0699. And if we look at what percent can do more than Jack, it is 0.0699. Okay, excellent. So we've got our first problem done. There are some other ways that we can also do this. So like this equation right here, if we want to figure out these areas above and below, let's do it by hand real quick. So the first thing that we would need to know is like our z-score, like how many standard deviations away from the mean are we? So if we were to do a z-score, it would be equal to our critical score minus the mean and divided by the standard deviation. That tells us how many standard deviations away from the mean I am. So I am 1.5 standard deviations above the mean. And if I want to know what percentage below, so if I do like percent below, so that would be, if I swapped these out, if I made this equal to 255, I made this like equal to 0, that was shading the other way. I can get this shaded region. And let's take a look at how I would get this shaded region. So the equation I would do would be norm dot dist, and I'd do the x, the critical point, here we go, the mean, standard deviation, and then it's asking if I want the cumulative function or the probability of mass function. For our continuous variables, we almost always want the cumulative distribution. So I'm going to type in true. Okay, now that gets the percent below our critical point. And then to get the percent above, we can just do the complement because the total area under our curve is equal to 100%. I know that from our critical point to the left is 93%. So I can just do 1 minus that percent below, and it's going to give me the percent. And that's basically what this is doing for us. 5 to 500, and there we go. Cool, so we've done it a couple different ways of how we can get this. Now remember, the z-score, oftentimes I'll ask for the z-score, and the z-score is how many standard deviations above or below the mean is our critical point. Okay, so it says, Harry also knows that just being able to have a massive clean is not a perfect indicator that contestants will do well at the games. In fact, winners had a clean weight between 185 and 246 pounds. What percent of CrossFit athletes or XFIT athletes are within the optimal zone for clean? Okay, so let's go ahead instead. Let's look at some quantile stuff. And from the left side, the smallest end, we could put in 185. And from the right, or the biggest number, we'd want 246. And the area between this, let's see. It is not being, let's see. Down, I have error going on. Oh, sorry. I am in the wrong spot. These are quantiles. We only put in percentages when we do quantiles. I made a mistake. If we're trying to look between values, we should use the between values one. So let's do this again. Sorry. Let's do 185 and then click on down here and we can do 246. So I was given some critical values and this shaded area is 82.09% or 0.8209. And we get the answer there. Now, if we were going to do this by hand, I would want to know the percent below and like 185. And then I'd want to know the percent below 246. And then I could subtract them from each other. So let's do that. Percent below 185 is going to be equal to norm.dist. And we have our critical point. Now this time our critical point for below 185 is going to be this 185, comma mean, comma standard deviation, comma true. And then for this one, I'm going to do equals norm.dist. And we have our right critical point. So we've got this right critical point, comma mean, comma standard deviation, comma true. And parenthesis, and I have now this value. Now between, we'll do percent between 246 and 185. Do that one. All we have to do now is take our bigger value, minusing off the little tail, and we're left with, again, our 82.09 as well. Okay, so there we go. We've got those ones and how they drop out. Okay, finally, Harry knows that athletes at the bottom 14% of the clean weights are not able to compete at the national championships. What's the minimum clean to be able to enter into the national championship? All right, so let's look at our quantiles and let's just say like where about is our bottom 14%? I'd say that that's somewhere around, I don't know, 210, maybe right here for a bottom 14%. So you have to be at least past the bottom 14 to make it into the competition. Now we're ready to do quantiles. So for here, the left percentage that we want is all the way at 0. And we want to go to the right until we reach 0.14. And here we have it shaded, and the right cut was at, so left cut is from negative infinity all the way to the right cut of 201.313. So we have to have a lift of at least like 201.3133 pounds. And there we go. So that's how we can use our normal distribution kind of tools and things here in Excel to answer these questions. So be really careful about how you label things. And then remember, quantiles are questions that that we're able to use when we have been given percentages and we need to find critical points. And then the value here, we have been given a value and it's going to produce a percentage. So this is a great tool. Hopefully it'll help you out on making your way through your problem.